Hi guys, hi folks. So in this tutorial, we're talking about solar thermal. We've got a perfect solar thermal installation here. I want to talk about installation hints and tips. I want to show you what a pump station looks like, what a track pipe looks like, and a cylinder. Enjoy. So let's start off looking at the controls. Here we have the control. The grey NTC, that's for internally. The black NTC, that is for externally. So with these controls, you always want the differential between 3 and 11. So that will keep the pump in. Here we have the pump station. This pump station is actually quite old. A modern pump is a PWM pump, and they use about 30 watts of electric. So technically speaking, solar is probably one of the cheapest sources to get electric out there. So you've got flow temperatures on it. Usually you get like a little bleed point on them, so you can get a sample to do your pH measurement, so you can see if the glycol's got bacteria in, if it needs changing. Here it's got a flow gauge on, so it can tell you litres per minute. Really, you're talking about 2 to 3 litres per minute. Just here, you've got your pressure gauge. So solar pressure is about 2 bar. The blow off is at 6 bar. Okay, so I have found a few faults here. See if you can find them. So the pressure relief valve comes off, comes all the way down to the floor. Now then, that could have glycol in and it could come out quite hot. So that should actually go to a sealed container with 25 ml of glycol in. So if it does blow off, the 25 ml will cool it down, because these can get to 200 degrees. The next thing, we have the expansion vessel. So the track pipe is insulated. That should not be insulated, because a vessel always needs to be the coolest place possible. Okay, so that should be down, it's in the correct position, it's on the return, the pump's on the return. However, it shouldn't be insulated. Now then, there should also be a cooling vessel. So just about there should be a vessel that connects to the track pipe, then to the solar. So any hot water will be dispersed and diluted to protect the vessel. So that's another fault. There you have the track pipe, which is going to the panel. So this is neat, this is good. It's got the correct insulation. So solar insulation will come with a black NTC in it, look, can you see that? This should have a fall on. It's got metal brackets. And if you come down, follow it through, you will see the compression. You cannot use solid connections, you cannot use PTFE or plastic clips, and they've got to have brass olives in. So the coil for the solar hot water goes to the bottom, the boiler coil goes to the top. So this is the insulation. It can handle up to 150 degrees. With this track pipe, you always have to fit the washers that come with it, because solar requires special washers that don't deteriorate under heat, high pressure. So yeah, so with that, you put the nut on, you crimp the flange on, then you put the olive on. So the solar coil. So 10%, the coil has to be 10% of what the panel volume is. That will prevent it overheating. The cylinder has to have 30% extra demand. So if you want 100 litres demand and you calculate to heat 100 litres of water, and the panel to heat 100 litres of water, you really want 30% extra. And that is the safety device. Because if you consider here, you've got volume for the solar thermal and volume for the boiler coil. If this just heated up the volume for the solar coil, it would overheat. So you always allow 30% extra to stop it from overheating. So this system on the return has got a flushing point on. So what you do is you put your power flusher on here, and you would flush the system out. Once you filled it up, you would flush it out for half an hour until you see no micro bubbles. If you get micro bubbles in it, you've got to keep flushing. Any air in a solar thermal can actually cause bacteria growth and jelly formation. So it's very important you get the air out. When you do a service, you inspect the water. If the pH level is bad, you flush it out. You put sanitizer in it for half an hour. You drain it all out, and then you put glycol in. You put glycol in, you flush it for half an hour to get all the air and microbubbles out, and then the system's good to go. So here, you turn that, and it'll be forced round your pumping station. So, go through, back in, sanitize it, put your glycol in, and we'll keep pumping it around until you get the micro bubbles out. Close it off. So whenever you use glycol, if it's for ground source heat pumps or air source, never really recommend an automatic air filter, because it can leak, it can let air in, therefore it will cause bacteria growth. However, this is a deaerator, which is better because a deaerator gets microbubbles out rather than air pockets. So I fully recommend this. This particular system has got an immersion, 3 kilowatt immersion in. So that's just backup really to supply the top unit. This system's got underfloor on it. Underfloor is most efficient for hot water because it's got low surface temperature. So let's go through this. So because underfloor works at 35 degrees, it's important that you put an inhibitor in that's got antibiocides in, so it kills any form of bacteria. If you fit on the floor and you put a normal inhibitor in, or none at all, the issue will be it will block, and to unblock underfloor heating can be quite challenging. So here you've got a blending valve. Just be apprehensive with these because some of them have a pin in that can seize. So you've got the flow that comes in, the return comes up, blends with the flow to lower the temperature. So that will get you 50 degrees. Here's the actuators, low voltage actuators. Here's the return. So on the top is the key, that's for regulating them. Always look at the water, see if there's much bacteria in it. You've got flushing points at the top and bottom. So this is an evacuated tube. These are the most expensive but most efficient. So whenever you fit a panel, you always leave the wrapping on it, because if you take the wrapping off, it'll be too hot for you to carry on installing and connecting it. And not only that, when you go to fill it up, you'll get a flashback or a steam bag where the water or glycol or sanitizer will go through the panel and turn up into steam in your face. So it's quite dangerous. So always leave it wrapped up until it's filled up and pressure tested. So a bit about these. This is a heated bulb type, so the water will go over it and then pass it again. How these work? These are filled up and sealed with a gas. When the gas deteriorates, you'll find that a barium paint will disintegrate. It's got a thin copper plate that's covered in a Murasol paint. Now that's a black paint that absorbs sunlight and heat. And in that copper tube, there's a fine gas inside that multiplies when it gets hot. Usually with these, behind that copper fin, you'll get a W plan of mirrors. So when the sun hits it, it hits the mirrors and bounces back on the actual copper plate. This one doesn't have it. Here we have a flat pack solar panel. Etching technology, so the sunlight can only go one way and it catches the heat. These panels are tested to extreme temperatures and pressures and freezing conditions.